is the Hadoop ecosystem that is supported by the Apache Software Foundation. The Hadoop system as well aims at creating a unified and sound analytics software stack, and they have a lot of systems to do that. So, of course, their Hadoop everything as well is based on the Hadoop file system, which offers redundant, reliable, and highly scalable storage. And the new Hadoop ecosystem contains Yarn as a very central component with their cluster management. And there are all sorts of applications that basically build on Yarn. So you have your classical Hadoop MapReduce. There are other systems like Tez. There are streaming systems. There are specialized. So Stratosphere on an existing Yarn cluster, but we're aiming at becoming a Apache Software Foundation project as well. So right now we're applying to become an Apache incubator project, and of course we will then integrate this Hadoop software stack even more tightly. So some key features of Stratosphere include some high-level APIs, such as a scripting language called Meteor. With Meteor, you can write query scripts that get executed in Stratosphere. There is also a high-level front-end for graph processing. It's called Spargel right now. It's basically, if you're familiar with other systems such as Google Gradle, Spargel is essentially Gradle on Stratosphere. So it offers a very graph-oriented way of processing data. And on the more general side, we have a new Scala front end that uses the functional language Scala to provide a query system. And then there's the very generic and, in some sense, legacy generic Java front end, which is called PAX. That stands for Parallelization Functions. And so one of the more recent developments is that we also aim at supporting iterative programs, which is very necessary for graph processing and machine learning. So a lot of these algorithms there are not just queries in a sense, but they're algorithms that do have loops in them, and we want to provide parallelization primitives for these as well. And that's actually one of the goals of the Scala front end and the Spargel graph processing engine. But all that essentially runs on the same engine, and also runs by Pact actually. And this engine is highly optimized for high scalability and for in-memory computations as well. And it plugs into this Hadoop ecosystem with HDFS and Yarn. So from a more comparative overview here, essentially, I think most of you are probably familiar with the Hadoop ecosystem. So you have the classical Hadoop MapReduce that the new Hadoop versions at least, usually runs on the Yarn cluster manager, which leverages the scalable storage from the HDFS. And on top of Hadoop MapReduce, there are lots of other projects that aim at being a little more specialized, such as Hive, which is this SQL on MapReduce, basically. For Stratosphere, we aim at a similar structure. So we have these front-end APIs. There's Meteor for the scripting. Well, these are those that I mentioned previously on the previous slide. But all these basically run through the same stack below. So there's a programs in a scalable fashion. So to be a little more specific, there are several entry points into the system. So as a user of the system, you can write your Meteor script or your Scala script. But what happens then is usually that these scripts get compiled down into a PAX program. You can write PAX programs yourself. It's not really hard. It's like basically it's a generalization of MapReduce. So if you can write a MapReduce job, you usually are also able to write a PAX program conceptually. And these PAX programs are run through a database optimizer, and then we have implementations of several operators that get executed inside a data flow engine, which is called Netlab. So, of course, you can, that's what's depicted here on the right side, you can program directly for Netlab as well. So there's little magic to it. It's just that this whole stack gets more and more general the lower you get. So these are basically Meteor is optimized for JSON data, PAX is optimized for tuple values, and on the Netlab level, you don't even have you don't even assume structured data anymore. It's just records that are serialized and deserialized, and they're being passed around. So the stack gets more specific once you get to the top, and more general when you get to the bottom of it. To give an overview, what happens when you write, for example, a Scala program, is that this Scala program, which is on the top left side here, is a very simple program that makes a join between two data sets, filtered orders and lines, and it's an equi join on an ID attribute, and it also contains a projection on a new record type, order total, that contains some data from the input relations. So after that join, there's a new data set, which is represented as a variable in Scala, and from that, basically you group by with an aggregate function to retrieve the final result of the Scala program. So that's basically the Scala program. This Scala program is then parsed and compiled into a PAX plan. This PAX plan consists of PAX operators. For those of you that are familiar with Hadoop MapReduce, they're the classical map and reduce operators as well, but PAX has more operators on top of that. I'll be covering that in more detail on the next slide. But this PAX plan is then run through a optimizer, which from the idea of it is a little bit like an optimizer that you have in additional database systems. So it will apply optimization techniques to this logical plan to come up with a more low-level execution plan. So for example, for a join, the optimizer would choose between a hash join and a sort merge join. And this execution plan then is put into a Netlab job graph for the Netlab data flow engine. And Netlab will then schedule this graph in parallel fashion on a compute cluster or an infrastructure as a service cloud. So to cover Meteor in a little more detail, it's a scripting language which is inspired by Jackal, which is, I think,